Okay, Mr. Hunt here with circle constructions and a couple other constructions, kind of random ones that they want us to know and we're going to throw in here that are fun. Alright, so a couple circle ones to start. First one is locate the center of the circle. So I'm going to do A, and then B is just another circle. You can kind of just repeat the same thing. Alright, so this one's pretty simple, just knowing the strategy here. So you're going to make a chord. And if you haven't done circles yet, a chord is just a segment whose two endpoints are on a circle. So I'm just going to make that point and this point. My circle is a little thick, but just really you don't need to specifically draw on those 2 points. As long as you have that, that's a chord. So really, the process on this one, I haven't written all these down fully, but it's a chord, and then you do a perpendicular bisector. Alright, so watch this. So we know perpendicular bisector, done it a lot. You're just going to go to this endpoint, I'm more than halfway. Semicircle, this endpoint, semicircle, and draw it in. So you're basically splitting the circle in half. You have two semicircles. So now, where's the center? I mean, you can't just say it's right there. It does just happen to be where the perpendicular bisector semicircles were. Where is the center? Well, we don't know. Okay, because this is a diameter. What we just found here to here is diameter. So you have two options. Do another chord and get another diameter. Or some people will like to just take the diameter you already have and cut it in half. Right? So I'm gonna do that one. So I'm gonna take this diameter. I'm doing a perpendicular bisector. So more than halfway. Going from each endpoint. So then I'm connecting those two. Okay. So right there, where those are two diameters basically, and that's where they meet. That's the center of the circle, that point. Now I also want to show you something here that you could also do. Oh, I put it down here at the bottom. That's right. For number one, now draw an inscribed. So the square is touching all the four of its vertices are touching the circle. It's just where the four diameter endpoints are. I'm trying to make it a little bigger. So this is just an addition to this one. We already found the center of the circle, but I'm just connecting these, and there's my square. Similar to when we made it earlier with the 45, 45, 90 angles. Okay, I'm on number 2A now. Right here, the left one. Construct a line segment tangent to the circle through this given point. Alright, so this one's a point on the circle, this one is this point up here not on the circle. Tangent is, if you haven't done circles yet, the term means, just draw a picture down here. So it's going to intersect the circle at one point. Alright, so just at one point, so right there we're going to make a line. A tangent is a line. A line segment is a tangent. That intersects the circle, just goes right through there. Okay, 2A's, B's not hard, but 2A's a little bit easier. What I'm going to do is, there's a theorem you'll learn about in circles if you haven't done it yet, that if you have a radius, 2 R's is what I think of, radius and a right angle. If you have radius and a right angle, well, that didn't help. Radius and a right angle on a circle. Radius and it makes a right angle there. It is a tangent line. So we can draw a radius. Okay. And I'm actually going to draw it further through just because we need it for the second part. But there's our radius, there to there. Right angle. Well, we know that's perpendicular bisector. Okay, so then what I'm going to do is I'm going to make a perpendicular bisector through this point. Now I need to know, alright, well, I need two endpoints to do a perpendicular bisector. So let's just, I could form two new ones. I already have this one though, so let's go with this. Here's my radius length, so shorten that a little. Okay, so I'm just going to go over here. So I put my compass at this point, pencil there, and just made that arc, and then same arc over here. So now I know that I can do my perpendicular bisector through, let's label them, through A and B. Okay, so I'm going to put my compass on A. I'm more than halfway. I'm doing semicircles. Sorry, I got off. I'm going to do the same thing. I'm going to do it with B. My point B was a little bit off there, that arc. Alright, so let's see how this might be slightly off. That worked out pretty well, actually. So you draw on that perpendicular bisector, and look at that. Directly through, we'll just intersects that circle just at one point. Okay, I'm going to do B as well through, we're going to do a tangent line, so from this point, like down to here, but the point this time is not on the circle. So in B, this one actually goes off a circle, a tangent circle theorem, and what we're going to do is we're going to make two tangent lines from an exterior point. Those tangent lines will be congruent. That's a theorem. And what it does is we're going to make congruent. The reason I'm telling you is why it works. We're going to have two congruent triangles, and so by forming these tangent lines, they will be congruent. First step. Let's see. I called this A and this B. Draw in AB. No need to go further through A this time. Now what we're going to need is we're going to need a point here that is equidistant from B and A in order to get arcs here that will intersect and be tangent out here. So I'm going to do a perpendicular bisector for AB. So there's basically three steps on this one. Draw an AB is step 1. Perpendicular bisector for AB is step 2. Let's move this for a second. So again, more than halfway. Drawing that perpendicular bisector, I called this point C. And then here's all you're going to do. We're step 3. We're about done. Set your compass on CA, this distance, which almost already is. Set your compass on CA and draw in 2 points. So I'm basically making radii. Let's see if I can do this without moving the camera. From an exterior point. So we made these 2 points. I'll just call it D and E. And so from these 2 points, that's where I can draw in. These will be tangent. I can draw it all the way through if I want. So again, there's this theorem for circles that those 2 tangents we just drew in are congruent. So is BA. And then if we drew in AD and AE, those would be radii congruent as well. So the triangle, if we drew in, again, this is not part of it, but if we drew that in, those 2 triangles would be congruent by side, side, side. And that's part of this theorem that it works towards. Okay, so I'm going to finish up with 6 and 7. 6 is a square, but with this side length. So we've seen it before where we could just start with nothing, and we made a 90-degree angle, and then we drew in the sideways. We drew a circle and made the sideways square. So that's for if we're given nothing. But if it says here's a side length, form a square, it's pretty simple. I'm going to basically employ the rhombus method, which we've done earlier for a parallel line. But what I'm first going to do, if this is one of my side lengths for a square, I need a 90-degree angle, right? That's the key part of a square. So here, let's call this A. Call this endpoint B. So I'm going to make a 90-degree angle at A. So to do that, I'll use B. That's fine. I could make my own endpoints as well if I want. Extend that line. Actually, yeah. I'm just going to use my own. We've done this before for a right angle. I need to make two endpoints. I could use B. I'm just going to make my own. So I'll do that one. And then okay, and then that one. Okay, so from those two endpoints here and the other one, I go more than halfway. Just make sure I'll do a little bigger. More than halfway. I like to do full semicircles. So there's one from this other endpoint. There's another. Connect those, and it should go perfectly through A. Okay, so I made a right angle. Then all I'm going to do is kind of the rhombus method. So I need all four sides to be the same, right? So here I'll get AB on my compass. So I put my compass on A, set it to a length of B, make that arc. I make the same arc up here. I go over to B. Oops. Go over to B. Now, so my square is going to be up here somewhere. So I make another arc from B. I go up to this. Maybe we'll call it C. I make another arc to find point D. So this I call it C, and then see the rhombus method is that last part, connecting those two. Okay, there we go. So there's our square. Just connect these. There we go. And so it made four congruent sides, and so therefore it's a rhombus. It's therefore a parallelogram. If there's one right angle, there are four right angles. So I could draw these in. Okay, last one we're going to do is a regular hexagon, 6 congruent sides, inscribed, so inside a circle. This one's fun. So first I'm going to make a circle, and since to make a circle I need the center, so basically I'm just going to put a point down. That'll be the center of my circle. Alright, you're then going to make a circle. I wouldn't make it too big or too small. Okay, so there's my circle. And I have the center. Here's what you do next. Choose any point on the circle. Any point you want. Well, let's call this center. Circle A. You can choose any point you want. Okay, then you need the length of that radius, which you actually should have because it was just the circle you drew. So you need that length if you want to check. I go like this. What I'm going to do now is I'm going to come down here and make that same length. What I've done, I could draw in, I'm not going to yet, but I could draw in an equilateral triangle. If you didn't know, a hexagon is made of 6 congruent equilateral triangles. Alright, so there's one. Now, but here's what I'm going to do. I'm going to make more congruent triangles. So then I'm going to start here. Do another one. There's another equilateral triangle I could draw in. And then come over here. Do another segment. I sometimes call this like the sun method. You're making these marks around, kind of makes it look like a big sun. I've also heard it called the Australian walk around, where you walk around and you put your compass, keep going. The ninja star method, that's another one. So I go there, put my compass here, go there. Now this one's very difficult to get perfectly accurate. Wow, this might be my best one ever. Seriously, I normally have difficulties, especially, it's mainly when I do it on the smartboard. But that one was like perfect. Alright, so then you can connect all of these to make your hexagon. And if you want to draw them through, which I will in a minute, I can then show you the equilateral triangles. Some of you might say too, well, couldn't you draw, I could have connected like here through A all the way over here and gotten a diameter. That would have worked. Save yourself a little bit of the steps. Okay, there we go. All 6 sides congruent, regular hexagon inscribed in a circle. Again, what I really did right here is I first made, I could have drawn this in to start, this equilateral triangle. And then I next made this one. And then I made this one, and right, so I made 6 equilateral triangles.